Welcome to Knowledge Share channel. Today in this video we will be discussing about Ohm's law and its limitation. So let's go without any further delay. So as you all know, Ohm's law plays a very vital role in finding the value of current or voltage or any resistance, whichever parameter is unknown, that can be found out. Out of these three parameters, that is voltage, current and resistance, if any two parameters are known, the other parameter can be found out by using the Ohm's law. Ohm's law is the first and foremost law which is being used throughout our electrical engineering applications. Why it is called as Ohm's law? Because it is found by a scientist named by Ohms. Hence it is called as Ohm's law. So I have given a brief introduction of what we are going to do with this Ohm's law. So from now on, what I will be discussing is, I will be giving you a formal definition for this Ohm's law, as well some statements. What is the statement that has been described in this book, and there are some limitations as well for this Ohm's law. What are those limitations? What it means actually? What do you mean by limitation? That is, Ohm's law can be applicable only for certain circuits. It is not applicable for all the circuits. That's where we are going to discuss in limitations. So in which type of circuits Ohm's law is not applicable? We should be aware. So first of all, before knowing the law clearly, we should always know whether this particular law is eligible to apply for this particular circuit. That's very important. Okay. So that's why limitations are very important, because we should not apply Ohm's law abruptly for all the circuits. There are some circuits, exceptional circuits, in which Ohm's law cannot be applied. So those things also we will be discussing. Okay. So let's move on. Ohm's law definition. What do you mean by Ohm's law definition? See, initially when voltage, current, resistance, we want to find some relation between them. Why we want to find the relation between voltage, current and resistance? Because they are all dependent on each other. Voltage, current and resistance are dependent on each other. When you change the magnitude of resistance, automatically the magnitude of current or voltage should change. So they are all dependent on each other. Okay, if they are dependent, so what we can do is, we can find the value of unknown parameter by knowing the values of the other two parameters. So for example, if you know what is the value of voltage and current, you can find what is the value of resistance. If you know what is the value of voltage and resistance, then you can find using this formula what is the value of current. If you know what is the value of current and resistance, then you can find what is voltage. So it's a very simple thing. Okay, now let's go into the discussions. For example, when a voltage is applied to a closed circuit, what do you mean by a closed circuit? Closed circuit is nothing but it has a starting point, and again it is going round the circuit, and finally it comes and the end point comes and connects with the start point. That's called as a closed circuit. Okay. So when a voltage is applied to a closed circuit, it should be a closed circuit. Okay. When a voltage is applied to a closed circuit, it will cause flow of electrons. Okay. I am sure it will cause some flow of electrons, and this causes the flow of electricity. And you know that there is a parameter called as resistance. in the circuit which is going to oppose the current flow. Okay, there is a resistance which is going to oppose the current flow. That we call it as R. Okay, then the actual value of current always depends on the applied EMF and the resistance in the circuit. Please remember, I will just repeat it again. See, the actual value of resistance in any circuit depends on the applied voltage. Okay, the actual value of current flowing in any circuit depends upon the applied voltage and the resistance of the circuit. Is it clear? So, for example, if your voltage is higher, the current should be higher. And if resistance is also higher, the current will proportionately decrease. Is it clear? So, this is what Ohm's law states, or Ohm's law's definition is all about. See, if I want to state it actually, how you can state, because statement is something like when the temperature remains constant, current flowing through a circuit is directly proportional to the potential difference across the conductor. Is it clear? So, this is how, for example, they may be asking you in 2 marks or something like that. You can write something like definition, but if they ask state Ohm's law, it should be a perfect one. See, when the temperature remains constant, current flowing through a circuit is directly proportional to the potential difference across the conductor. What do you mean by potential difference? It is nothing but the EMF or voltage. Or mathematically, what we can say is voltage is proportional to current when the temperature remains constant. Or what you can say is V equal to IR, where R is the constant of proportionality and that becomes the resistance. Hope you are all clear. Okay. So, I have given enough discussions and enough explanations related to Ohm's law, I am sure. Okay. So, now let us move on. Okay. So, this is what the statement is looking like, okay, which I have explained to you at present. Okay, the temperature should remain constant. The current flow is always proportional to the EMF applied, and the relationship between the parameters what we have discussed. So, always the applied EMF and resistance and current are interdependent in nature. Okay. This is what finally we have concluded from the definition and statement. So, now we will move on with the next slide. As I have already told, this Ohm's law is having some limitation. What do you mean by the limitation? Limitation is nothing but I cannot apply Ohm's law to all the circuits. For example, Ohm's law is not suitable for non-metallic conductors. Is it clear? It is not suitable for non-metallic conductors. As well, it is not suitable for non-linear devices. It is not suitable for non-linear devices. And also, it is not possible to apply this Ohm's law if the temperature changes with respect to time. So, this is one more parameter. The temperature should remain constant. Only then the Ohm's law can be applicable. So, where do we use this Ohm's law? The Ohm's law can be used for, that is called as application. Is it? So, the Ohm's law can be used for solving for, to find the magnitude of the current, the magnitude of the voltage in the circuit. As well, you all know that we will be discussing in future something called as mesh and nodal analysis. In both mesh and nodal analysis, we cannot solve both any circuit using mesh and nodal analysis without knowing the Ohm's law. So, Ohm's law plays a very vital role in solving any circuit using mesh and nodal analysis. Please remember. Anyway, I will be solving some problems in future in the same channel, and you will be coming to know that I will be using mesh analysis and nodal analysis to solve some larger circuits, and we will be applying Ohm's law and in the mesh and nodal analysis. Hope you are all clear what I am trying to tell. See, this is a triangle which is called as Ohm's law triangle. See, you can just write something like this, VIR. That's all. Please don't by heart anything. See, for example, if you want to find what is the voltage, you can just use V equal to I into R. If you want to find what is the value of magnitude of current I, then you can put V by R. If I want to find what is the value of resistance, then I can put V by I. Very simple. This triangle is called as VIR triangle and also called as Ohm's law triangle. So it is simplifying your visualization of understanding the formulas or remembering the formulas. So no need to by heart the formula. Normally V equal to IR is the general formula. From this we can derive. But anyway, this power triangle will give you as some easy understanding of solving for any given circuit. Thank you. So we'll move on. So this we have discussed. Ohm's law states that current flowing in a circuit is directly proportional to the applied potential difference and inversely proportional to the resistance of the circuit. So this triangle also has been discussed, Ohm's law triangle. So V equal to IR is the formula. Okay. So hope you are clear with the discussions. So now we will solve one problem. Okay. So here there is a circuit. In this circuit, a 50 volts is applied and a 10 ohm resistance is there, and you can see that the current I will be equal to V by R. That is I equal to 50 divided by 10 ohms, which is nothing but I equal to 5 amps. Okay. So this is one of the most important formula, and this is type of problem has been asked in many of the gate circuits, gate question papers. So very simple to solve. They will be giving you the value of voltage and resistance, so that you can find. Now there is one more method of asking the question to find the value of resistance. So in that case, as you all know from the triangle, you can understand that R equal to V by I. So the voltage given is 220 volts and the current is 5 amps. So 220 divided by 5, which is nothing but 44 ohms. So it's very simple to find, very easy to find. So this is how the problems related to the Ohm's law can be solved. Okay. So if you really like this video, please give a thumbs up. Any queries or anything, you can leave a comment. And if you really like that this particular video will be useful to someone, you can share it. And if you really like the videos which I post in this channel, please give a subscribe and support my channel. Thank you.